Assalamu alaikum, dear students. As you know, in the previous lecture, so we have gone through the concept of the determinants and the solution of the determinants. We have solved the determinants using various techniques, especially using properties of the determinants. Now, in this lecture, we will be discussing some applications of determinants and matrices. So before discussing these applications, I would like to highlight here the consistency and inconsistency of a system. That's actually the system of equations. A system of equations is said to be consistent if its solution, one or more, exists. And a system is said to be inconsistent if its solution does not exist. So here in this chapter, we will be dealing with the system of equations, system of two equations and system of three equations. So we'll restrict ourselves to up to system of three equations only. So for the solution, what we have to do, if case number first, it is if A is a non-singular matrix. We know that if it is non-singular matrix, then its inverse exists. And in that case, as you know, for example, we have a system of equations that's like this. So we can write it in the matrix notation. So this A, X is X, Y, Z, and B is equal D1, D2, D3. So this is AX is equal to B. So this is AX is equal to B. A is actually the matrix of the coefficients. X is the matrix of the variables. And B is the matrix of the constant terms. So this is AX is equal to B. Now the first case is like this. If A is non-singular, means determinant of A is not equal to 0. And we know if a matrix is non-singular, its inverse exists. If its inverse exists, you can write it like this. A inverse, we can pre-multiple this equation, our equation, by A inverse, and we have A inverse into AX is equal to A inverse into B. You know, we will use the associative law now. A inverse into A, that's equal to identity matrix, and this is equal to A inverse into B. So the solution is like this. X that we are supposed to find, that's equal to A inverse into B. Now, this inverse, you know how to find. So we'll be finding the inverse, A inverse, and multiplying that with B. That is the solution of this given system of matrices. So it's in that case when the solution exists, when the determinant of A is not equal to 0. So whenever such a solution exists, the solution is always times unique. The matrix provides a unique solution for the system of equations, as inverse of a matrix is unique. You know it. Matrix whenever exists, inverse of a matrix whenever exists is always times unique. This method is known as matrix method. Next one is, next case, that is, if A is a singular matrix, that is determinant of A is equal to 0. Determinant of A is equal to 0. In this case, we have two subcases. That is, we will first of all find adjoint of A into B. If that's not equal to 0 matrix, then the system does not have a solution and it's inconsistent. However, if adjoint of A into B is equal to 0, then the system is either consistent or inconsistent, according as the system will have either infinitely many solutions or no solutions. Okay. So the exercise now that we will be solving are based on these concepts. So the exercise will be solved in the next class. Thank you for joining the class.